The next part of the section 2.4 is going to talking about surface area. So what is the surface area? Let's looking at a definition of how to find a area or a surface area of a cylinder. But this time, this cylinder is a hollow. So it's just like we're just talking about the outside piece. Then for this piece, we can break it. You can thinking about I cut it here, and then I'm able to break it as a piece of square rectangular shape. And for this one, we know how to find the area, which is the width times the length, where the width is corresponding to the height here. Now the length is going to be corresponded to this piece, which is the circumference. There's no L. So the circumference is going to be 2 pi r, where r is this piece. So how to find the surface area if I have like a random graph? So if I have a random graph, in order for me to find the surface area, I have to rotate it. Assuming I'm going to rotate it along with the x-axis. And this is the shape I will have. Again, this is hollow. It's not a solid, it's just a piece of fabric. Then if I want to find the surface area, I'm going to slice them as usual. Then when I sliced it, what I will have this kind of cylinder shape where the height is going to be this. So this piece is going to be the height or the width. And this one, we're going to using the arc length to find it. Then the circumference or the radius in particularly is this much. But for this case, which is the y value. So long story short, when we try to find the surface area or S, you're just thinking, this is not looks like S. You're just thinking about we are taking an integral, or we are using the circumference, the 2 pi r, multiplied by the height which is the arc length. And of course, we are talking about slicing them, we're talking about integrals, antiderivatives. So with the integral symbols, the surface area is actually going to be the integral from a to b of either 2 pi y multiplied by 1 plus dy dx squared dx, or is going to be 2 pi x 1 plus dy dx x squared dx. Okay, so is 2 pi x or 2 pi y is literally depends on what is your r. If I'm rotating along the x-axis or I'm rotating along the y-axis. And this piece, which is the arc length. And for the arc length, we also have the dx version and the dy version. It doesn't really matter which one you're going to choose, dx or dy, just depends on which one is easier to work with. Like the function they give you is in terms of y equal to some complicated x or x equal to some complicated y. but this is the concept of the surface area formula. This hopefully this way it help you to memorize the formula a little bit easier. And then let's looking at an example. So the example we have is I have f of x, which is equal to square root of 1 minus x. Is over the interval 0 to 1/2. And I want to find the surface area of the surface generated by revolving the graph of f of x around the x-axis. So square root of 1 minus x, which is going to be, do a really quick sketch. Okay, isn't that a nice graph? But literally this is a sketch. And we want to do it from 0 to 1/2. So 0 to 1/2. So you can see that is the piece. And then we're going to rotate it. So rotate it along the x-axis. So this is the area or the shape we have. And we're going to find it, the surface area, by looking for the arc length multiplied by the 2 pi r, where r in this case is going to be the y. So formula, the surface area is going to be integral, I will wait, 2 pi r, which is the y, or f of x. I'm going to write it in terms of f of x, multiplied by square root of 1 plus f prime of x squared dx or dy. Because I have y equal to square root of 1 minus x, so I'm going to do dx. Okay, so because this is dx, so I know everything is going to be written in terms of x, no y here. And because of that, we're going to using this 0 to 1/2, because those two are the x value, of 2 pi y, which is square root of 1 minus x, multiplied it by 1 plus the derivative of square root of 1 minus x, which is 1/2. I'm going to write it here. So f of x is square root of 1 minus x, then f prime is going to be 1/2 times 1 minus x to the negative 1/2 times negative 1, the chain rule. So it's going to be negative 1/2 multiplied by 1 over square root of 1 minus x squared dx. Simplified and multiplied it a little bit. We got 2 pi 1 minus x square root of 1 plus 1 over 4 1 minus x dx. Pull out the 2 pi. Square root of 1 minus x multiplying this one inside plus 1/4 dx, which is going to be 5/4 minus x dx. I can let u equals to 5/4 minus x dx is going to be negative, du is going to be negative dx. So we're ending up with 2 pi integral square root of u negative du. Then when x equals to 0, u is equal to 5/4. When x equal to 1/2, u is going to be 5/4 minus 2/4, which is 3/4. So we will end it up with negative 2 pi multiplied by 2/3 u to the 3/2 evaluated at 5/4 to 3/4. Negative 4 pi over 3 multiplied by 3/4 to the 3/2 minus 5/4 to the 3/2, which is 8 3 square root of 3 minus 8 5 square root of 5. And multiplied everything and moving things a little bit. So I want the positive number to the front, so I will end it up with 5 square root of 5 over 6 minus pi minus square root of 3 pi over 2. Another example we have is I have the graph x equals to, or the curve x equals to 2/3 y to the 3 over 2. And I only want the portions y from 0 to 3, and it's rotating about the x-axis. So the graph, or a quick sketch, is x equal to 2/3 y to the 3/2, which from y from 0 to 3, which is about this kind of curve from 0 to 3. And then we're going to rotate it along the x-axis. So this is the three-dimensional graph we will have, or sketch we will have. This is x equals to 2/3 y to the 3/2. And we're still going to rotate it along the x-axis. So this is our slice. So the radius is still going to be the y. Now let's do the setup. The surface area, or S, is going to be an integral from one point to the other point. The circumference is 2 pi y, 2 pi r, multiplied by square root of 1 plus f prime squared. And because this is my x equals to 2/3 y to the 3/2, y is more complicated, so I want it to be dy. So in the same thing, I want this one to be dx dy squared dy. And also because of dy, everything needs to be y. So this one, I'm going to keep it as the y, not going to be in terms of x. So I'm going to integrate it from y from 0 to 3, 2 pi y, and square root of 1 plus the derivative of, so pretty much the x prime, 2/3 y to the 3 over 2 is going to be 2/3 multiplied by 3/2 y to the 3/2 minus 1, which is 1/2, square dy. Now we're going to simplify them. We can put the 2 pi out, 0, 3, y square root of 1 plus y dy. So 2/3 times 3/2, that's going to be 1. Y to the 1/2 power square, which is just y. Now we're going to doing the u substitution. I'm going to let u equal to 1 plus y. So y is going to be u minus 1 and du is going to be dy. So now become to 2 pi integral y is going to be u minus 1 times square root of u du. Multiply them, which is u to the 3/2 minus u to the 1/2 du, and using the power rule to find the antiderivative. Now, when y equal to 0, u is equal to 1 plus 0, which is 1. When y equal to 3, u equal to 1 plus 3, which is 4. So we ended up with 2 pi times 3 over 2 plus 1, which is 5 over 2. So 2 over 5 multiplied by u to the 5 over 2 minus 2 over 3 multiplied by u to the 3 over 2 evaluated from 1 to 4, which is going to be 4 pi over 5 times 4 to the 5 over 2 minus 4 pi over 3 times 4 to the 3 over 2 minus 4 pi over 5 times 1 to the 5 over 2 minus 4 pi over 3 times 1 to the 3 over 2. We're 4 to the 5 over 2, that is going to be 2 to the 5th power. So 2 to the 5th power times 4, which is 2 to the 7th power, minus 2 to the 3rd power, 2 to the 5th power over 3, minus 4 pi over 5 plus 4 pi over 3. We ended up with, I'm going to use the calculator, and I got 232 pi over 15. And that is what my answer is. Okay, so let's kind of quickly wrapping up. The whole concept for finding the surface area is we're going to using the circumference 2 pi r multiplied by the height, where the height is going to be the arc length formula. you can choose if you want dx or dy depending on the original function. If your original function is simple on y, complicated on x, you can do dx. If it's simple on x, complicated on y, you can do dy. And then it really depends on, or it is interchangeable. Then for the circumference 2 pi y, normally speaking, I do not want to come up with any kind of rules you can follow, but normally speaking, if we're going to rotate it along the x-axis, your radius r is going to be the y. If you have dy, you're going to keep as y. If you have dx, you're going to rewrite y in terms of a function f of x, which means x. If you're going to rotate along the y-axis, which we do not have an example here, but if you're going to rotate along the y-axis, then your radius is going to be the x. Still the same thing. If it's a dx, you leave it as x. If it's dy, you have to rewrite x in terms of y, thinking about f of y. But the arc length portions is interchangeable. It doesn't really matter. So you do not need to follow like how to set up your arc length. So from my experience, I don't see anyone have problems setting up the arc length. But I do have students confusing of the r portions. Some problem just give me y by itself. Some problem give me the wrong y's. So that is the wrong r's. So make sure this you're going to pay attention to the setup portions. And that's pretty much it for the section 2.4.